Welcome back everybody, my name is Dustin. In the last video, we went over how we're now using CMake and how to build our engine in Linux. So I've also made some other changes in the background to make it a bit cleaner for us. I've added some assets to the editor so you can actually run it without it crashing. So it has these textures now. I changed a few things around. So in the scripts, we now have this platformer because that's going to be the game that we're working on. And I've changed some things around, so it's a bit cleaner now, and we'll just go on from there. So I recommend you grab the latest from the Scion2D GitHub repo. And if you haven't built it yet, follow the build instructions, get everything you need, and go from there. All right, so we're going to be continuing using CMake from here on out. However, I'm still getting used to using it myself. So if you see a better way to do something, please let me know in the comments below. So today's video is going to be a little less structured, and the goal for this video is to create the state machine and eventually have the player that can shoot projectiles and move around using this new state machine. So I've already been kind of working on this on not necessarily the main project, but in a test project. So let's take a little look at that now. So the goal, maybe if not the end of this video, the end of the next video, we're going to be having this right here. So let's take a little look at that. Cool, so basically the same engine that we have, same thing, but we're going to change the player out for this player. I got this player off of Open Game Art, and we'll go over that. And we're going to want to be able to shoot projectiles, and I'm going to change the jump. You see, so now the jump, you can, however long you're holding the jump button, determines the height of the jump. So if you just tap it, you just jump slightly, and if you hold it, it jumps higher. So then you also have a double jump, and now you can't just keep jumping. I fixed that, so you can't just jump forever. And you can shoot and jump. That's the goal for over these next few videos. Okay, so we're going to need to make state machines and stuff like that so we can actually get this guy to do what we want him to do. But before we get into any of that, we have lots of work to do to get there. First thing I want to do is actually get some fonts. Let's actually open up the project that we have going on here. So what I like to do is open up Visual Studio, and you're going to want to open up a local folder. See, I've already had it open. So go to your folder and go to wherever you have your Scion and open that up. And this will open up the CMake project for you. If we go here and we go into our application, we have the fonts. So when we go add fonts, right here, I have this commented out right now, so we're not actually loading the fonts. We want to do this from memory. That's the goal for now. I want to have the default font that the engine automatically has when you run it, because the person may not have loaded fonts, and we don't want the engine to crash just because you don't have fonts. So we're going to actually have some default fonts that we're going to store in memory. Okay, so we're going to actually use the add font from memory function that we created previously. So let's go get some fonts, and we're able to download some free fonts at fontspace.com. So let's just go to that right now. We're going to want to get the 100% free, royalty-free fonts so we can embed it right into our engine. Now, I remember the one I want is on, I think, page 6. It's a pixel style font. I like the pixel style. And no, maybe 7. You could probably search up the type of fonts. This looks good here. 100% free. Cool. Download. And then open up your downloads folder here, and we're just going to want to extract this out here. Extract files right here is good, because we actually want the TTF font. This is what I want right here. So the .ttf file. So I also have a BinConverter here. I created this project here. It's a binary converter. So what it does is it'll take in your binary or the TTF. It takes in different, you can use textures, PNGs, JPEG, and it'll make you an H file or a Lua file if you want. Later on in the engine, this will be embedded in the engine, but right now it's not. So it's just a separate program, and it allows us to convert the binary to an H file. So what you can do for this is just download this, the BinConverter. If you just go to the BinConverter repository, download it, and use the CMake as well. So you just build it the same way that we're building the engine. However, right now in Linux, when I'm trying to build it in Linux, I'm having this weird faults with GTK and all that. It's not working in Linux. It's not building successfully. However, on Windows, it is working. So build that up and then get it running, and I'll show you what we do. So this is the binary converter. So once you have it running, all we're going to want to do is take our TTF font here, our public pixel font, and drag it in. So you can just drag it and drop. See how it goes into the in file. So now it knows that it has the font, and we want a C-style array, and we want an extra table size variable to name. And what we want to name this, we want to call it pixel font. So what's the name of the table that we're going to name it? Or array. Table if it's Lua, array if you're using C. I should probably have that where this will change based on what you have selected here. So we'll just call this pixel font. and we want to set our out file. Okay. And for us, I have it, put it anywhere you want because we don't really actually want the file itself. I just want the data after we create it. So this is good here. And we'll just call it pixel font, .h, then save, and then just generate table. Cool. So we successfully generated it. And if we go to that folder, desktop, right here, it created this file, this pixel font.h file. So if we open this up, as you can see, it's just an array, an unsigned char array with all of these hex values. So if we go down to the bottom, and we also have this here that says our font size so that we know what the size is of this here. Cool. So now that we have that, let's just open up our engine, and we're going to want to go to core, and inside of core, in the include core, and then resources, I've already added this fonts folder. Okay, so in this fonts folder, we're going to want to create a new file. So add new file, and we'll call this default fonts.h. So now that we have that file, if you see here, CMake is doing something. So what it's doing is it's checking, it's going to be adding it to the CMake file. As you can see here, this has a red check mark now. That means that it's changed the file. So if we go into CMake here, if we go down to the bottom, it added this file in automatically for us. It saw that it was different and it needed to add it, so it added it in. Now, it just places it at the bottom. It doesn't really have a rhyme or reason. So if you want, you can take it and put it into a different place. So just cut it out and put it with the asset manager up here, or just leave it wherever. And we go into our default fonts and just copy that in. So take this, Control A, Control C, go into here, Control V. We're just pasting all that in there. So we have that. Even though the stuff was free, I still want to put the information about it in there, right? So not this one here. Let's go to our downloads and let's grab this info here. I want to take all this and just copy that and let's paste it up here as a comment. Cool. All right, so we have our pixel font. There's a few ways that we can do this. We can just add this in the application, or we can have the asset manager control it. So what we can do right here, we could do it in the constructor, or we can just create a new function here and go bool, create default fonts. And let's copy this. So now that we're using CMake, for some reason, it's not letting me just create it automatically, but that's okay. We can just do it this way. Go into resources, asset manager CPP, and right here, paste that in, add this here, and Control K, Control D, Control K, Control D, because we have the Clang format now. And up here, we're going to want to include that new file. So we go include for resources fonts, default font. Cool. Now that we have our default fonts, we can create our default font. And we can just go if not add font from memory. And we're just going to say pixel, because that's what we called it. And we want to have the pixel font. That's all we're going to need. Then we can do our Scion error, failed to create pixel font. And just return false. And return true. Cool. Now you can add other fonts here as you like. So you can say to do, add more default fonts. But right now we just need the one. Cool, now that we're done that, we can go to the editor application file and remove that temp font that we added because we should now have a default font that we could use. So let's do that now. Go to application. So we already had this here. We can uncomment this. Then we can get rid of this. Change this to add font or create default fonts. Remove everything from inside. Failed to create default font. Cool. Now we should be able to run this. Let's try to run it and see what happens. All right, so it's not showing our fonts because I commented that out. So let's actually go into that file. Let's go into our assets, scripts, platformer, game states, title state. I commented these out because we didn't have the fonts. And I think we can just run it again. It should copy them over. Yeah, awesome. See, these are our new fonts that we just added in. So we have title state. I hate that L. We have title state and press enter. And cool, it's running. Now it's pretty slow because we're running in debug. Let's close this and change this to release. We need to add a release. So we don't have a release here, so we need to go to close this. We need to add that in. Yeah, so we have to manage our configurations here. And I'm going to want to add here plus, and we're going to want to have x64 release and select and control S, but we save it. And it's going to allow us to do release now. There it is. There's our release. Let's change to release. We can close this now. Cool. CMake is happy. All right. So now we're running and it's much faster in release. So it's working. It's doing its thing. Good enough for now because we got a lot of changes that we want to make. Cool. So let's stop this. So there's still errors there. If you notice, there's still errors because there's no sounds. Like I haven't provided any sounds, but we're going to go grab a whole bunch of that stuff from Open Game Art. That's another goal that we have. So in our assets here, I added the folders, but there is no sounds. So we have font folder, nothing there, no sounds. We do have the textures now. We have some shaders. Okay. Awesome. Now that that's building in release and everything's working the way we want, so we have our platformer here. And currently in our game state, that's where we're doing our updating of the player and like all this stuff here, right? Update player is just in game state. Rather than it having the player having its own state machine and moving around, eventually we're going to want to have the ability to shoot and all that other stuff coming from the player and be able to jump. It'll be much easier to like, and we want to have different states, death state, move state, wait state, stuff like that, hurt state. So if the player gets hurt, you want it to go into a different state for a little while and maybe be invincible for a few seconds so you can't constantly be getting hit. So that's where state machines come in. So if we go up here and into our Scion core, we have our states and we have our state and state stack, right? So in state stack, this will be used for your different scenes and if you're going to be popping different states onto the game. But you're going to want to have a state machine for a player, okay? The state machine is going to be a little bit different. You won't necessarily be pushing and popping states. The player will start with all their states already loaded and you'll just switch in between states or you'll be changing states accordingly. It's going to use the same state. It's going to have all this stuff here, your on render, on update. You may not use them, but they're going to be there, okay? So we're going to want to add that in now. So let's go here and go Control A and add new file. And that's going to be a StateMachine.h. We're going to want to have the same stuff here, Scion core, state, but we're not going to have a vector. This time we're going to have a map. So let's copy this, go here, and paste that in. This should also say Pragma once here. Pragma once. Oh, we have our Scion core. And we're going to want to have a class state machine. And let's get our map in there. So include map. I guess it could be unordered map, but we're just going to use map. We can change it later if we want. And we can go std map. And it's going to be std string. And we're going to have a std unique pointer to the state. And it's going to be m map states. Cool. Actually, let's put private here. And we're going to have a string to the current state, so std string ms current state. So that's going to be the state that you're currently running. Then we're going to have an std optional sol table. and it's going to be a state table. And we're going to have a void. Actually, let's ignore the state table for now. That'll be an option. So public Control K, Control D. Cool. So we have our state machine. Then we'll have another, and this one will take in the console table reference, and this will be the state funcs. Then we say void change state const std string reference state name. What state do we want to change to? And do we want to remove the state? That's going to be false. We'll say remove state. Oh, do you actually want to remove the state from your map? Then that's what this is for. If not, then you just leave it there. And we're going to have one more, and it's going to be a sole object reference. Let me make this const. No need to change it. And it's going to be the enter params. And that's just going to be sole lua nil t. Now we may not need enter params. That's why it's defaulted as lua nil. Okay. If we go back to our states here, we have the onEnter function. Well, this may take in some parameters that for the onEnter, what do we want to do when we enter that state? That's why it can be nil. If it's not nil, we'll do something with it. Cool. And it's going to have your typical void update const float dt void render void add state const state reference state void exit state void destroy states and std, let's say const std string reference current state const turn ms current state. And then our last one is going to be our bindings. So static void create lua state machine. That takes in a sole state reference. Cool. All right. So it actually looks like it's happy right now and it's seeing all this, that we can make these. I don't know where this will make it. Let's just see. Cool. In StateMachine.cpp, where's that going to put it? It's my first time using CMake, right? Well, not my first time, but my first time actually working on the same project with CMake. We'll see where it puts it. Hopefully it puts it in source. When I did that, it actually crashed. It created the file, but it created it in the wrong spot and it crashed. So I don't want it there in the states of the include. I actually want it in the source. So we want to go to states and we're going to drag this into there. Cool. I'm not sure if it added it down here. So it added this state machine here. Take this, cut it, and where's the, right here, state stack. Right here, we'll do state machine. We'll actually copy this down, change this to source, add this to CPP. Cool, it's that easy. Awesome. So that's our StateMachine.cpp. And now I'm going to want to take all of these here. Let's see if it does it where I want it to go now. Oh, dang it. Okay, so that doesn't actually work. For some reason, it may be just my version of Visual Studio, but it actually is crashing my system. So we're not going to do that again. We're just going to copy the functions over and do them that way. So let's just copy these and paste. So first I'm going to want to go include states, state machine. Then I want to say namespace Scion4. Paste these in and add all the stuff we need. Cool. All right. Takes a bit longer that way. Let's just generate this, see what it does. Cool. It was unhappy. Is it still unhappy? Ignore that for now. Deal with that as it comes. Cool. So we have all our stuff we need. So in this constructor, we'll just call the other constructor. So StateMachine, and that'll just be sol.lua nil t. And the other constructor is going to say mStates, mCurrentState, ms current state. And mStateTable, state funcs. Cool. So what the state table is we can have a table of states sent in, and it will run those instead. So we'll have this here, if mStateTable. So we're going to change states. It's going to check to see if this is good. Then it's going to go in here, and it's going to call change state table. And then it'll take in the state name, B, remove state, and the object or enter params. And then just return. But we're not going to worry about that right now. It's just going to be commented out. We're going to add that in later. Let's just get the basic one working, and then we'll work on that one later, okay? What we are going to want to do is we're going to want to find the state that we need and change to that state. Let's actually put this off to the side, get more space here. And change to that state. But the difference between the state stack and the state machine is all your states are most likely already going to be loaded. The chances of you popping a state or taking a state off is low. That's why remove state is usually false. And we got to get rid of these default values. Cool. So we're going to say auto state iter is equal to mStates dot find, and that's the state name being sent in. Then we want to say if state iter is equal to mStates dot end. This is, we're just going to have an error here. Let's add our logger in. So include logger, and we can go Scion error, failed to change states. Does not exist. And then we just send in state name and then return. If it does exist, we're going to want to check get the new state. So we'll just call it the new state. Auto reference new state is equal to state iter second. Then we want to see if the current state is empty. If the current state is empty, we just want to set it to the new state. But we don't have to worry about calling on exit for the old state because there is no state, right? So we go if ms current state is empty. Let's go ms current state is equal to state name. Cool. Else. So in here, we're going to want to get the old state. Then we're going to want to call our onExit function. So we're going to go auto reference old state is equal to mStates dot at ms current state. Then we say if old state on exit is valid. Go in, we'll say try, then auto result is equal to old state on exit. Then check to see if the result is valid. And if it's not valid, we want to throw a sol error. and then just throw the error. Cool. And we're going to catch it. Catch const sol error reference error. This is where we are. Scion error. Failed to exit state. And give the error. That's error.what. And then just return. So we have a problem here that we'd have to fix. Cool. So we do call our on exit. And now we want to check to see, just like before, you don't want to kill or remove states when you're inside of this, because you're most likely calling the change state during an update or something like that. So you don't want to kill it during an update, because then you're going to kill the current state that we're in, and we don't want to do that. Okay, so if b remove state, then we're going to want to go old state b kill state. Is that what we called it? I think we did. Yep, b kill state, and we have b add state as well. Cool. Let's go back to CPP, and then right here we're going to want to say ms current state is equal to state name, because we made it to here. Cool. So we did all that, and then finally when we get out of here, now we're going to want to call the onEnter function on our new state. So we want to go new state. Let's check to see if it's valid first. So if new state onEnter dot valid, then we're going to go try auto result is equal to new state onEnter, and that takes in our enter params. Then if not result valid, throw our sole error. So basically the same as above. Scion error failed to enter state. Error.what. And return. Cool. That's basically all we have to do for that. All right. And for our update function, we just want to go try. Then we want to go auto, and we'll say state iter is equal to m states, m map states, map states dot find. And we want to find the current state, ms current state. So if state iter is equal to m map states dot end, we're just going to want to return no error, because we might not be in a state yet. So we don't want it to update if there's no states. So say the current state is an empty string, it's going to come back as the end of the map. So it's just going to leave. So we're not going to want to update. Okay, cool. And if not, we want to go if state iter second on update dot valid. Then we want to say auto result state iter second on update, and that takes in DT. So the same as always, we're going to want to check to see if not result valid, throw our sole error. And we'll just put the catch here right now. So we'll say catch console error. Say console error reference error. And we'll say Scion error failed to update state error dot what? And we'll just keep going from there. There could be another catch here. Copy this. Failed to update state, and this one's going to be an unknown error. Cool. Okay, and while we're updating, since we're in here, we might as well do our std erase if. So we check for if there's any states to remove. So check for states to remove. Std erase if. Don't know what it's. That takes in m map states, and then auto reference state, return state dot second be kill state is equal to true. Well, you don't have to do that. Just return kill state. And that should erase the states for us. So the render states is basically going to be the exact same as the update. So just grab all this, copy, paste, and change things accordingly. Render. Let's get this out of here. Only have that in the update. Change this to on render. And this doesn't need DT for render. Cool. I think we got it all. Fail to render, on render. Cool. So there's render. And add states, pretty straightforward. So we want to say if m map states dot contains, and that's going to be the state dot name. We're just going to have an error here. Scion error failed to add state, and we'll put the state name already exists. We don't want to add it in if it's already there. State.name, and just return m map states dot in place state name std make unique state take in this state. Cool. Couple more. We're almost done this. So now we want to do the exit state. So we can say auto state iter is equal to m map states dot find ms current state. Then we want to say if state iter is equal to map states dot end. Scion error fail to exit state. State does not exist. Cool. And we'll just say ms current state. Just return. And if so, we want to go state iter second on exit. And we're going to kill the state here. So if you're calling the exit state, we actually want to kill it. I should probably call it kill state. It'll be kill state. It's equal to true. And then just ms current state clear. So now we don't actually have a state. Okay? Because you're basically just saying exit now, do and kill the state, be in no state. You're not telling it to change to another state, so that's what it's going to be. And the last one, destroy states, is pretty straightforward. All we're going to want to do is call on exit on all the states and then just clear the map. And clearing the map should erase all the states for us because they're unique pointers. So once the map is clear, they go out of scope. It should call the destructor and do all that stuff itself. Okay, so for auto reference name state in map states, we're going to want to say state on exit. Cool. And then map states dot clear. Cool, that is it. So that's basically it for our state machine. Now we have to do our bindings for Lua, so we can call this in Lua. And it's pretty straightforward. We've done this before, so we just want to create a new Lua user type. So Lua.new user type state machine. And we'll call it state machine. So call constructor. So constructors. State machine. And state machine. This one takes in a const sol table reference. Cool. So then we're going to have change state, and we're going to have a couple overloads for this. So we're going to have sol overload, and here we're going to have state machine reference state machine const std string reference state bool be remove and const sol object reference enter params. Cool. And this will just be sm dot change state, and it'll take in all the params. So state be removed and the enter params. Cool. That's one. Control K, Control D, clean it up. And we have to do our next overload. This should be there. And we want it right here, comma. We can just copy all this here. And we're just going to put the default values. So this one, we don't want to add the enter params. Just get rid of this. Get rid of the enter params here. And we'll do the same thing again. Paste that in, get rid of this comma, get rid of that comma. Change state. Do need this comma. And we can get rid of everything except the state names. Let's get rid of all this. Cool. Get rid of enter params, get rid of remove. Cool. So when we're in Lua, we can call each one. So if you want to add the remove, you can add the remove, the enter params, stuff like that. Cool. Control K, Control D. Cool. I like how that looks. Comma. So then now we need to do the update function. So update. The last ones we can just directly call the function. So state machine update, render, current state, add state, exit state, destroy state. Destroy states, destroy. We can just say destroy. It makes sense because state machine, you're destroyed, so you're destroying the states. Exit state, add state. I'll just do all these first. Current state and render. Change all these. Render, current, add, exit. Cool. I think that's everything. That is everything. All right. So that's there. That's here. So we're messed up here. I need to have this comma here. This needs to be down here like that. There we go. Control K, Control D. Awesome. There we go. So there's our bindings. So we can generate this. So we have some errors, but we'll fix those shortly. So now that we have our state machine, we're going to want to go and do our bindings in our script system. So go to our core systems, script system, but we want to go in source, system, scripting system. And where's our stack? So here, let's add our state machine. State machine. Find where we're doing the stack, put it right there. So we can just copy this line, Control D. State machine, create, Lua, state. I think that's what we called it. Oh, this takes so long. Let's just go to state machine and copy it. So there are some changes with CMake where it's a bit slower to run for me anyways. Cool. We should be able to run this. Let's make sure all our CMake stuff is good. So we have our state machine. So it keeps giving me this error. I'm not sure why. But what I'm going to do, yeah, so it looks like it's unhappy and it's not letting me do any build or anything like that. So I'm going to close this and reopen it. So it's still not letting me do anything. So what I'm going to do is actually go out, delete all those cached files and start over. So here in Scion2D, I'm going to delete this out folder. This is automatically created from Visual Studio. So delete it. Cool. And then we're going to reopen the folder here. Visual Studio. And reopen. Yeah, so somehow we lost our configuration. It's confused. CMake generation failed. Fine. Not find source core states state machine. Okay, so it's not seeing the file that we added. Let's see if we put it in the right spot. So Scion core. What do we have open here? Scion core source states state machine. What do we call it? So okay. So source is that's my problem right there. Sorry guys. So in source, it just goes right to states. There is no core. Okay, get rid of this. So I had nothing. So CMake was right. It was yelling at me for being stupid. Good. And it should go now. So if we try, Continue. It's confused again. Regenerate. Generate. No errors this time. Cool. Now we can build. So let's set this. That makes sense. Because it wouldn't be there. It would be in 4 states. Did I even make the state table? Did not. So we have a lot of errors. I kept putting states instead of map states. So error. All right, looks like everything's working properly now. Previously, I wasn't doing it correct. So state table we didn't actually make. So let's go into states, include core states, StateMachine.h, and we might as well add this. But we're not going to use it. StateMachine. Cool. Sorry about that, guys. Yeah, so since we started using CMake, it works a little bit differently than what I'm used to previously. When you're used to one thing, trying to switch over to another thing, you got to learn its quirks and quarks. But I like it better because I can easily make it cross-platform with CMake, where before I was just using the Visual Studio solution, and your hand is kind of held all the way through. Okay, so that should build now for us. Cool. So yeah, it works. Everything still works. Cool. We got our state machine now. Close this. Ignore the errors for now. We'll deal with all that stuff later. Can I go to release? Yeah, so I deleted all that stuff, probably for no reason, because I didn't understand the error that I was getting. So we're gonna have to add that again for the release, so we can have release mode. So here, add it in. Another release. Yep. Cool. Save it. Should be able to change our configuration to release. Let it do its thing. Cool. Not really sure what that's trying to say, but let's try to build it in release just to make sure. Let's close this for now. All right, yep. So builds and release, we're good to go. All right, now that we have the state machine, we're going to want to actually create state machine stuff inside of our actual game here. So on our assets, we're going to want to add stuff in here. But first, before we start doing this, let's go get some stuff from OpenGameArt to help us make this. So I already got OpenGameArt here. So we want to go with CCO, and we just want to say Mega Man or Mega Bot. That's the one I was using in the previous video that you guys saw. Search here, Megabot Asset Pack. And you're going to want to download this. I've already did it. I'll download it again. So just make sure that if you are using this, that you credit Ansimuz for the work. It's actually done really well. We did have to make some changes though in order for it to work for us. And I'll go over that right now. So here, you just want to open up your assets here, extract the files. Cool. So we extracted those. Now, the only problem with these is they're set up as single files. So if you go to player here, it has like the idle, the jump. It's just one, or like see how there's two. So if we just open this up, so it has 4 shoots. So we go skip. So they're all individual. What I had to do was I took each individual one, because we don't have the texture atlas or sprite atlas capabilities yet in our engine. I made this into a sprite sheet, and it ends up looking like this. So I ended up putting all the textures together in one sprite sheet for us, and that's what we're going to use here. Watch this here on how I did that. Cool. Now that we have the sprite sheet, we can continue. So what you're going to want to do is you're going to want to add that sprite sheet to our assets. So let's do that. Before we do that, let's get a few more assets. Let's get some sound effects, and we're going to want to have it CCO as well. And let's just say jump. We may not add these in today, but we will add them in eventually. 8-bit sound effect pack. Sure, we'll take that. Let's grab the whole lot. And we'll get some music as well. So let's just go music, get rid of the jump, get rid of sound effects, search, 5 chip tunes. Yeah, this is the one we want here. And make sure that even though it is public domain, make sure that you're saying thank you to Jahuni Jankala. I can't say that name correctly. I probably butchered it. But make sure you give them some credit for doing the work. So let's grab this, and we'll start adding that in later. First thing we want to do is actually get the player to move around using our new state machine. So that's the goal. All right, and then make sure that you add your new player sheet to the assets file or assets folder in our Scion editor so that we have that. And don't worry, this is going to be getting pushed up to GitHub as well. Just make sure you add the necessary credits for these sprites. Cool. All right, so let's open up the engine. And the first thing we're going to want to do is actually make sure that we're adding this in. So we go to platformer and asset devs. So I have this new folder named devs. Open this up. And we want to make sure that we have that in there. So we can we're not going to use this player sprite anymore. So we're just going to change this to player sheet. That's what it is. And we can just leave it as player. So that's what it's going to be. If we run it now, it should change a little bit. So right now, yeah, because it didn't copy the assets over, we got to make sure that it's copying the assets over. Okay, so let's just do a clean build. And build, it should do that for us. Now, it should have copied the asset over, but we'll see. No, it did not. I wonder why. Textures, player sheets in there. Do I got to close and open it again? So weird. Did it copy that time? There we go. So you have to reconfigure the cache. So as you can see, it's all messed up. It's not working the way we want. We're gonna have to make adjustments for that. But we do have the character in, and it is pseudo working. All right, cool. So we got our new character sheet. Now, before we keep going, let's take a look here at our main.lua scripts, main.lua. And you see how we're loading all this in like this? Well, eventually there's going to be hundreds of scripts. Like if in a normal game, you're going to have hundreds of scripts. So we're not going to want to actually do it like this. So we're going to actually create a new function that will take in a Lua table of script names, and we'll call that the script list. So what we're going to want to do is go here and go up to our core, and we want to go to source, systems, and scripting system, and we find our run script function, and we're going to have to add a new function right here. Okay, and we're going to want to say Lua, and we're going to actually make some changes too. All of our functions that are from the engine, we want to actually add a little prefix to it. We know that it's coming from the engine. So we'll say set function, and then we're going to say S2D, and then we're going to say load script table. And that's going to take in a reference, console table, reference. That's going to be our script list. And then first thing we're going to do is check to see if the script list is valid. So if not script list dot valid, we're going to want to have a function here. So we're going to want to have an error here. Scion error failed to load script table or script list. Let's say script list. Table is invalid. Invalid. Cool. And then we return. Okay, Control D. Oh, it's being all weird for me. Cool. So now, if we make it here, we know that the script list is valid. We're going to want to loop through all the scripts and basically just call your run safe script file on them. Okay? So we want to go for const auto reference. This is going to be on index, so what index it is, and script. And we're going to pass in the script list table. Script list, that's our table. Cool. I'm going to try. Bring this down, go in a bit. Cool. We're going to go auto result is equal to lua dot safe script dot as std string. Then we're going to check to see if the result is valid. Not result dot valid. Throw an error. So error is equal to result. I'm off a lot today here. Equal to result. And then throw the error. Throw error. We'll catch it here. Console error reference error. Scion error failed to load script. Error. So we'll pass in the script. And the error. Error.what. Cool. And we're not going to want to continue from this. We're just going to return. We want to deal with one error at a time. We don't want a whole list of errors. Cool. And that should really be it. Control the K, Control D. Cool. That's our function. So we have this new function, S2D load script table, and that's going to take in a sold table. All right. That should work for us. And let's quickly go through and add our new prefix, S2D, to all of our functions here. We might have to go through and fix everything, but that's fine. Get ticks should also be get S2D, measure text. I want to know where it's coming from. Like if we just say get ticks, that could be coming from Lua, but we want to know that this is an engine function. Okay. Same with all these, and we'll do that later because these ones are definitely used. Or that you guys could do that. Go through and fix all of these, add our new prefix to them, and go from there. Kind of like this one here, yeah. Same as this entity in view. All right. Now that we have that, let's save it and go to our assets scripts and our platformer. We're going to want to open up here and go add new file, and we're just going to call this the script list.lua. And the script list is just going to be a table, script list. And what we can do here is just go to our main.lua and take all of these, pull that out, go to our script list, just paste it in here and get rid of all of this. Add commas. Fix any errors. Cool, there we go. Now we have a nice table filled with scripts. And now before we finish this, we actually have to go back into main.lua and it needs to know about this table. So we actually have to run this script, okay? So that's the one script we have to run. So we go S2D run script. And that's going to be, where is that? Assets, scripts, platformer, script list. So we can just copy basically one of these lines here. Let's just copy this from here, paste it in, and take out this defs, change this to script list, script list.lua. So now that we have that, now we can run our script table, S2D load script table, and that should just be script. Cool. And that should run as before. Let's just verify that's what we named the table. Script list, copy this, go to main, paste it in, and we will run it. Let's generate our cache again so it knows. I forget where that is. Right here, configure cache. And run it. And it looks like it worked. Awesome. So it's doing everything that we want. And what we can do to check that to make sure that it has the correct file is, because the assets are supposed to be getting copied over, what we can do is go to our Scion, go to out, build, release, bin, assets, scripts, platformer, script list. Awesome. So it's going right there. And we open up main, we'll just open it in Notepad++, and it should have our new stuff, and it does. It's exactly what I want. Close that. All right. So now we should be ready to actually start the character and character states. All right, so the first thing we're going to do is actually go into our scripts, platformer, and let's add a new folder. We'll go add folder, and this one's going to be character. And inside of character, now your enemies and your players are both going to be characters. So we'll put them both in there. And in here we'll add another folder, and we'll call this player states. Cool. We're not going to be doing enemies in this video. This video is already going to be taking a long time. Okay, so now that we have that, before we do any of this, we need to create a definition. We've done this before. If you've been following along, we did asteroids and ship definitions in those videos. So we're basically going to be doing the same thing. So inside of our defs, let's add in some more defs, so new file. And this one is just going to be player def. So we can just say player defs.lua. Cool. And that's going to be exactly what it is. So we're going to say player defs is equal to, and the first character, I'm just going to call him Dustin. You guys can call him whatever you want, but I'm going to say Dustin. And then we're going to have a tag. That's going to be player. A group, no group. We'll just have an empty. Then type, we're going to have type is equal to player. Because the character, we're going to go into character next, but a character will have two types. Player, well, three types probably. Player, NPC, or enemy. Okay? And we'll say components. That's going to be a new table. And we're going to have a transform. That's going to be position is equal to vec2. And right now we're just going to start it at 16 and 416 because that's where we're starting the player. Scale is going to be equal to vec2, 1, 1. Then we're going to say rotation is equal to 0.0. And we're going to have our sprite. And it's going to have a texture. It's equal to the player texture. We're going to have a width. The width for this case is 32 by 30 and 32 for height. And we're going to have to start X, start Y at 0. And layer we'll put to 3. And then for animation, so it has the num frames. That's equal to 4. And we'll have frame rate is equal to 10. Frame offset. In this case, there is no offset. And B vertical is not vertical. So by vertical, it's like vertical scroll. Are we scrolling vertical? No, we'll be scrolling horizontally. And is it loot? Yes. So B loot is equal to true. Cool. We're going to have a circle collider. Circle collider is equal to, and then we have a radius is equal to 8. And offset is equal to vec2, 8, and 12. And then we're going to have our physics attributes. So we're going to go physics attributes. So we're going to have the type, and the type is equal to a dynamic body. So the body type dot dynamic. Density, just have it 75. Friction, restitution will have a 0. Restitution is your bounciness, if you remember. And position. And for position, we're just going to hard code this right now to vec2, 16 and 416 because that's what we're using for our player. We don't want this to always be the case. We're going to want to have that just at 0, and we'll be setting this when you create the character. But right now, this is good for our uses. Radius is equal to 8. B circle is equal to true. B fixed rotation is equal to true. Now we have our object data, another table. And so we'll have a tag, player, no group. Let's just have empty. Bring this down. And B collider is equal to true. B trigger is equal to false. Cool. All right. So now we're ready to actually go and create the character class. Inside of the character, let's create the character class. So new file, I'll say character.lua. I'll say character is equal to table. Character index is equal to character. Function character create or construct or whatever you want to call it, and I'll take in the character definition. So then we'll have local, this is equal to table. Now we're going to say mdef is equal to the def. So we always have access to what the definition is. Entity ID is going to start at -1. Start os, start at vec2, 0, 0. Be initialized. Be initialized, I think I spelled that right. Equal to false. Be dead, false. You don't want to start dead. Be facing left, equal to false. Be jumping, false. Be grounded, equal to true. Type to def.type or default as player type. Then we have controller. The controller is going to be what we use our state machine. So we're going to send in the state machine. And name is equal to def.name or not 0 or just empty. And we'll put the comma here just in case we need to add more stuff in. Because we're using this as both player and enemy, you may want to add in more stuff based on that type or have a new struct that holds on to the types. Okay, so that's a good basis for what we have for now. So now we can want to go like this. We want to go local entity def is equal to nil. Start it off as nil. Then we want to say if this.mtype is equal to player, then we're going to want to go to the entity def is equal to player defs at def.name. So we actually have to make sure that this goes in. So you have to send the name in. Then we want to say else if this.mtype is equal to enemy, then entity def is equal to enemy defs at def.name. Now we're not going to worry about enemies or NPCs right now, but we're just going to throw that in there. Then we want to go assert entity def, then string format failed to get the entity def for def.name. I think that's correct. So now we want to load the entity. Okay. Now in our utilities function or our utilities, we should have a load entity from previous. So let's go into utilities. I think we have that load entity. We do, but we're gonna have to make some adjustments here because this is we created this file when we did, or not this file. We created this function when we did the asteroids game. So we need to adjust this for the new changes that we have. Like we don't do this anymore because we actually have bound GLM since then. So we don't have to send in X and Y. We can just we just get the position itself. Okay, so yeah, right here our transform, we can actually just change this to take the position by itself. The position is now a vec2. We don't have to do vec2 anymore. We actually keep the column, get rid of this, because it is a vec2. Cool. Same with this one for the scale. Cool. That's our transform. Good. Sprite's the same. Oh, we have an asset name here. Let's change it to texture. Cool. Let's quickly look. Num frames, frame rate, frame offset, vertical. Go back. Cool. That looks good. All right, so we need to add another one here for the physics. So if we have physics or a physics attributes, then we're going to want to add a physics component. So we go if def dot component dot physics attributes, then and local phys adders is equal to def dot components dot physics attributes. Then we say local new physics adder is equal to physics attributes. Let's try this again. Physics attributes. And now we want to set all of our types. So we can go new dot e type is equal to phys adder dot type. Pop this line. Density. And it's going to be the same thing all the way down. So let's put in all those in. Then we also want to see if it is a sensor. So B is sensor. We can just say or false here. We can do that for all of these B's or all these Boolean values, or false, or false. B sensor. And now we want to do the object data. Dot object data is equal to object data tag group B collider B trigger. And then we want the new ID. So what do we call this? New entity right here. New entity ID. Cool. And now that we have that, we can actually do our physics component. So new entity, add component, physics comp, and that takes in the new physics attributes. Cool. That should work for us. All right, so now that we have adjusted our load entity, we can actually go back into our character and now load this entity. Okay. And load entity returns the ID, so we can go this dot m entity ID is equal to load entity and that's going to take in our entity def. Now we want to assert that entity ID is not equal to -1 or nil. Assert that this dot m entity ID is not equal to -1. Failed to load entity, or assert that it is there. Cool. And then we want to say this dot m start pos is equal to entity def dot components dot transform dot position. But we'll do this first. It's equal to this dot m def dot position, or get the position from the entity def. Okay. So if we're sending in the position here for a def, or you can say params, that might make more sense with parameters. Sending in the position, and if we don't send in the position, we're taking it from the defs. Well, so whatever is in here. Okay. Then we want to go. So now we want to actually check to see if the player has a controller. So if it has a controller, we're going to want to initialize it. So we go if entity def dot controller, then self init state machine. That's going to take in the entity def and this. So that means we have to create this new function. But before that, let's just quickly set metatable. This and self. And return this. Return this. Cool. So here, we got to make this function now. And then it's function character, and it's StateMachine end. So first thing we're going to do is check to see if character dot is initialized. So if we're already initialized, don't do anything because we've already did this. MB initialized, then just return. Then we're going to go local state is equal to nil. Now if character dot m type is equal to player, then assert that character states exist. Character states does not exist. And if it does, we want to say states is equal to character states. Else, copy this line, enemy, and we want to basically do the same thing but change it for enemy states. Copy. And cool. So now that we have our states, we want to loop through all the states and add them into our state machine. Okay, so we go for name in I pairs def.controller do end. And we're going to say local state is equal to states at the name. Assert state exists. State, let's go string format state does not exist. And if the state does exist, we want to say local instance is equal to state dot create character. I want to say character and controller add state, and it takes in the state. Cool. That's it. Now I see here it's saying state create. So what does that mean? That means we actually have to create this state. So we need another Lua file for that state, and we'll get to there in a minute. And then from here, we want to change the state. So we want to go character dot mController change state def dot default state, and change state has false and nil. So we're not removing the state and we're not setting in any parameters. Okay. Character.mb initialized equal to true. Cool. So before we keep going here, we need to go and create a state. And for our character, we'll just start with the move state. That'll be the first state. So we'll go player states up here, add new file, and we'll just say move state dot lua. Cool. So move state, we'll just say move state is equal to, and then we'll say move state dot index is equal to move state. Then we want to create our state. And that takes in the character that we're going to be controlling. And right here we go end, and we want to assert that the character is not nil. Then say local this and character is equal to character and entity ID is equal to character dot m entity ID and controller is equal to character dot m controller. Because this is going to be the player and I wanted to have a gradual jump, the jumps need to be done in steps. Okay, so we need to go m jump steps is equal to 10. Number of jumps, we want 2, but we'll just have, we need something that tells us which number of jump that we're on. So n num jumps is equal to 0. And we want to say mb attacking is equal to false. Cool. Just some simple stuff to start with. We're not going to go through all of the state yet, but we need to actually start creating everything. Making a state is the same as we did before. We need to actually make a state and return the state. So if we open up here, just game state, right here, game state.lua. We need to do all this state, set variables, set on enter, on exit. We need to do all this stuff here. Okay. So here we'll do that. We'll go local state is equal to state move. So that's a move state. And we'll say state set variable table. That's this. State set on enter. That's function. And now this one on enter can take variables. So we want to send in the on enter. It can be nil or it can take arguments. So we want to make sure that we have that in there. State set on exit. On update. Update takes in DT. And then on render. And for us, this is just going to be an empty function. It's not going to do anything. Cool. Now we want to set the meta table. So set meta table this cell, and we want to return the state. Cool. And now we have to quickly make our on enter, on exit functions. So let's just go function, move state, on enter, end, exit. And this one takes in param, update, takes in DT, on render, which we don't need. That's good for now. We'll just get rid of this. All right, so we'll go through all that shortly, but now we have our state, and we need to go and add all of our new things. So we need to add our move state, our player defs. But before we do that, we actually have to add our character state. So here, we want to make sure we go character states. That's just another table. And we're going to have move is equal to move state. Cool. And before we get there, let's just assert that move state exists. Move state does not exist. Cool. And then we have to go down here and add a controller variable. So after the components, we want to add the controller. That's just another table, and it's going to have the move state. That's all we need right now. Then we're going to have a default state, and that's going to be move. Cool. Let's go into our script list and add these in. We need to add these in down here. It's here. Change this from game state. Actually, we need to be above game state. Let's do it up here, right after the trigger system. We'll add in our move state. And just the move state. And then we are in characters slash, what is that? Player states. Move state. Cool. Then we have to have our defs. So right here. Platformer, defs. Not deads, defs. Player defs. Then we have to have our character. We'll probably put the defs up higher. Let's put that up here. Characters, character.lua. Cool. Is that everything? Did we add everything? Anything else that I'm missing? Move state. Character. Okay, I think we're good. So now we actually have to go into our utilities, and we need to add in our characters. So up here, let's add some new stuff. We're going to want to have active characters. So say active characters, and that's going to be a table. We need to have a way to know which characters to update and what to do and who to remove and stuff like that. So we need to have a table of active characters, and we'll have function add active character, and we're going to hold on to that by the entity ID for the key and the character. And all that is active characters at entity ID is equal to character. Cool. And we can just copy this, paste this. Then we want to say get active character, and we want to get it by its entity ID. Then we want to make sure that this exists. Assert string dot format character with ID does not exist. And then we'll send in the ID, TID. And then if it does exist, we want to return it. Return active characters at entity ID. All right. We want to have a function to clear the characters. So say when we leave a level or whatever, we clear all the characters. Function clear characters. So for K, V in pairs of active characters, do active characters at K is equal to Now we'll probably have to do other stuff here. This is just to get us going. We're probably not going to use this right now, but we're going to have to kill the entity and all that stuff. But let's just keep going from here. To do fix this to actually destroy the underlying entity. Cool. Then we can just say function update active character DT. And we just want to loop through all the characters and update them. So we can say for V in pairs of active characters do v dot mController update dt. And that's it. Awesome. So now that we have our characters, our active characters, we got to go to game state and add in a new character. Game state. Okay, so here, all this stuff for our character needs to come out, right? So we can actually get rid of all of this. Let's just delete it all. And we'll start from scratch. So we still want to have our G player, but we want to go local character is equal to character create. And that's going to take in the name. So it's a definition or a params table. Name is equal to Dustin, because that's the one I want to grab. That's the definition I want to grab. Now you can add your other stuff here as well, but we're not going to do that. We say G player is equal to entity entity of the character entity ID. Then we say add active character G player at ID and the character. Cool. Then if we come down to our update function, so we have our update player here. We're going to want to just comment that out for now. Actually, let's leave this open for now. Then we're going to say update active characters and send in DT. Now, do we add DT to update active characters? Let's make sure. I don't remember. Update active characters, DT, yeah, okay. And what I'm going to want to do now is do our cache. So let's go to, what was that again? Project, configure cache. Cool, seems to be happy. And let's try to build. Cool, we have some errors. Let's fix these. In player defs one, move state does not exist. That's because where we put player def. So let's go into our script list. Here, yeah. So it can't be before the move state, right? So what it's doing is it's checking to see if move state exists. So it's running this script, but we haven't run this script yet. So we need to actually move this. So yeah, I was right first time I put it here, and it should run. Okay, so we have a different error probably. Oh, that's this. Cool. So utilities at 14. Let's go see what that says. So utilities at 14 here. Active characters entity. What did I miss? Again. Ah, I missed that parentheses there. Run again. So move state, still unhappy. So it's saying that it doesn't exist at that particular place. Assets, scripts, platformer, characters, player states. Asset, script, platformer, character, player states, move state. Let me see. Assets, scripts, platformer, characters, player states, move state. Assets, scripts, platformer, character, character. That folder should be characters. Cool. Let's do our cache again and try to run it. Yeah, you guys probably already saw that. Something so simple can just wreck everything, eh? Cool. Fixing all our errors. Character 61. Character 61. Another one right here, parentheses. It's because I'm using string format here. Run it. All right. So stopping here, that means it's got an error. Utilities 107. Let's go see what that is. It's in the load entity. Utilities 7. Right here, B sensor. So we must have called it something different. The B is sensor. Yeah, so it's is sensor. So this should be B is sensor. And let's just quickly go to our defs, player defs. What did we call it here? We didn't call it anything here because we don't, it's either a sensor or isn't. Doesn't have to be in here because if we go back to here, we have that or false. Cool. Run. Probably got some more errors. Yep. Character 58. No value def. 58. Character 58. That's right. So it wouldn't be def.controller because we sent in entity def. So let's actually change this to def. There we go. All right. So yeah, everything's a bit off. If we're gonna have to set it accordingly. Awesome, great. So we don't have our debug function anymore, but we're not really using the move state. It's not really doing anything, right? So let's go check this out here. That's just plain sounds that we don't have. Let's just see if we're actually updating the move state. So right here, it should automatically put us in the move state because that's our default state. So let's go into our move state here and just add in print inside of move state. And run. Should be, as soon as we go in, it should be logging that. Cool. So yeah, we're in the move state. So all I want to do now is, we're not going to worry about the special jump and all that stuff right now, because that'll take too long to go over in the attacking. This video has already gone on for a long time, so I've made a very long video here. So what we're going to do is we're actually going to take this stuff here, the update player. I want to take this 100% out of here, add it into its own. We'll make changes in the next video. So let's just comment this out for now so it's not doing anything. And we're going to have to bring it to the move state. And then just paste this all in here. And we're going to have to make some adjustments, okay? Because on the update, we're not sending in the player. We need to get the player now. And the player was just an entity. And we already have the character, right? So all we have to do here is go local player is equal to entity self.m entity ID. That really should be it. Let's see, what else? Or yeah, the B left, that's going to have to be changed. That's going to have to change to, what do we call it? Facing left, B facing left. So copy that, go to move state. Anywhere you see B left, we want to change that. So let's go Control H. We want to replace that with self.m character.bm facing left. 3 places. Anything else we have to change? I think that should work. And let's run it. Awesome. So now this is 100% run from the move state. Now we're not leaving this state, but we did enter this state, and that's great. Cool. Let's actually just verify that it's all working. Go here. Completely delete this function because we don't need it anymore. That's been removed from game state. Completely remove the update player because that doesn't exist. Cool. And we'll run it. Play. Awesome. So as you can see, we have a problem with our collider. It's not in the right position. So we're going to have to fix that. If we go to our player defs here, we do have an offset here for our circle collider, but we're not setting that in our utilities. So let's go to our utilities and go to circle collider here. Now let's go take a look at this particular component, ECS, components, circle collider. Let's see what the constructor looks like. So yeah, we do have 2 constructors here, and one does take an offset, a vec2 offset. Okay, so let's go back into our player devs, and I think we just called it offset. Yeah, so circle collider dot offset. Go back to our utilities here, comma, copy the line down, and just put offset. Not offsets, offset. And run it, and it should be offset now. Look at that. Perfect. Okay, so that's it for this video. There was a lot done here in this video. So what I recommend you guys do now as a challenge is to see right now we jump no matter what. I jump the same height and we can jump forever. So the goal is you want to be able to jump. So if I'm holding it for a split second, it should only jump a small amount. And then when the longer you hold it, the higher you should jump to a certain point, okay? And then we want to be able to jump at a certain point and then do a double jump. But the double jump is basically the max jump. You don't have to worry about the hold for the double jump. So if you do here, if you do a small jump and then a big jump, that should work fine, okay? All right, that's it for this video. Give the challenge a shot, and hopefully you enjoyed that. All right, take it easy.